step into the realm of Lumen Spiritus, the light of spirit, a channel dedicated to exploring spirituality and the esoteric. Join us on a journey of enlightenment and discovery as we delve into the mysteries of the unseen. In this video, explore the mind-bending theory that linear time is confined to a planet's gravitational field. Journey into the fluid realm of time, discussing time loops, dilation, and the interconnectedness of past, present, and future. Dive into this video, filled with mind-bending insights. Re-watch it to fully absorb the fascinating and thought-provoking info. Each viewing unveils new layers of understanding. Have you ever wondered, does time actually exist beyond the confines of our planet? A question that challenges our conventional understanding of time as a linear arrow, always moving forward from the past, through the present, and into the future. But what if time isn't so rigid? What if it's more fluid and less constrained by our earthly perceptions? What if indeed it is bound to the gravitational field of a planet? Today we'll explore the possibility of time existing only within the gravitational field of a planet. Before we dive in, let's challenge the traditional concept of time as a rigid, linear progression. Imagine for a moment a river. In our everyday understanding, time flows like this river from one point to another in a straight line. But what if time is more like the ocean, with currents swirling and interweaving in a fluid, non-linear continuum? Yes, the idea of time as a fluid, non-linear continuum challenges our ordinary understanding, but it's not new. Philosophers and scientists have been grappling with this concept for centuries. The Greek philosopher Heraclitus famously said, "No man ever steps in the same river twice." He was hinting at the idea that time, like a river, is constantly changing and flowing, never the same from one moment to the next. Fast forward to the 20th century, and we find physicist Albert Einstein revolutionizing our understanding of time with his theory of relativity. Einstein proposed that time is not fixed, but flexible and relative to the speed of light. He suggested that time could slow down, speed up, or even bend under certain conditions. This idea, known as time dilation, is a cornerstone of modern physics. But perhaps the most radical perspective on time comes from contemporary thinkers like Elena Danaan. In her books, Danaan proposes that time is not just fluid, but interconnected. According to her, past, present, and future moments are not separate, but exist simultaneously in a sort of cosmic tapestry. So, what does this all mean? It suggests that time might not be a rigid line, but more of a fluid entity, shifting and changing, full of possibilities. It opens up a world where time loops, where past and future can influence each other, where time travel might not just be the stuff of science fiction. As we can see, time might not be as straightforward as we once thought. In the next scene, we'll explore how time operates within the gravitational field of a planet. But for now, let's sit with this idea of time as a fluid, non-linear continuum. Let it percolate, let it challenge our preconceptions. Because sometimes, to really understand something, we need to see it from a different perspective. Now that we've established time as a fluid continuum, let's delve into the theory of time existing only within a planet's gravitational field. Imagine it like this. As we move away from the center of a planet, the pull of gravity lessens. Now, if we apply this to our understanding of time, we find that time too is affected by this gravitational pull. The closer we are to the center of a planet, the slower time appears to move. This phenomenon is known as gravitational time dilation, a concept brilliantly explored by Albert Einstein in his theory of relativity. Elena Danaan, a noted author and thinker, offers an intriguing perspective in her books. She suggests that time is not a rigid linear progression, but a fluid, non-linear continuum. It's not a constant ticking clock, but a river that ebbs and flows with the pull of gravity. To put it in simpler terms, think of time as a rubber band. When you stretch it, the band expands, much like time would in a less dense gravitational field. Conversely, when you release the tension, the band contracts, mirroring how time behaves in a denser gravitational field. This theory also implies that time might behave differently on other planets, depending on their gravitational fields. For instance, a day on Jupiter, with its immense gravitational field, might feel much longer than a day on Earth. It's also worth noting that this theory challenges our conventional understanding of time. We're used to viewing time as a one-way street, always moving forward. But if time is a fluid continuum influenced by gravity, then it's conceivable that it can flow in any direction, forward, backward, or even sideways. This concept of time is not just fascinating, but also transformative. It compels us to broaden our perspective, to consider the possibility that our understanding of time is not absolute, but relative to where we are in the universe. This theory gives a whole new perspective to our understanding of time, doesn't it? But what about time in other densities or in black holes? Now that's a question that piques curiosity, doesn't it? This is where the concept of time becomes even more fascinating. Imagine for a moment a reality where time loops exist. Instead of time progressing in a straight line, it loops back onto itself. Past, present, and future are not separate entities, but rather interconnected moments in a continuous cycle. Mind-boggling, isn't it? Now let's talk about black holes. These cosmic phenomena are known for their immense gravitational pull, but did you know they also have a profound effect on time? It's a concept known as time dilation. In a black hole, time slows down. The stronger the gravitational field, the slower time passes. These theories further challenge our conventional understanding of time. So let's keep questioning, exploring, and marveling at the enigma that is time. After all, isn't that what makes the journey more fascinating? Now that we've explored these fascinating theories, what do you think? Ponder over the idea of time as a mere construct, bound by the gravitational field of a planet. How does this shift your perception? Could our understanding of time as a rigid, linear progression be an oversimplification? What if it's a fluid, non-linear continuum instead, where past, present, and future moments are interconnected? Think about the implications of time loops and time dilation. What if you could loop back to any moment in your life, or experience time at a different pace? What would you do differently? Consider the viewpoints of renowned philosophers and scientists, and those of Elena Danaan. How do these perspectives resonate with you? How do they challenge your current understanding of time? Now let's venture beyond our planet. How do we perceive time in other densities or in the extreme conditions of a black hole? Could our concept of time be completely irrelevant in these contexts? As we delve deeper into these theories, it's clear that our understanding of time is far from complete. The more we learn, the more questions we seem to have. We hope this exploration of time has sparked your curiosity and left you with more questions than answers. After all, isn't that the nature of true learning? Drop us a comment below if you'd like to see more intriguing and thought-provoking videos like this one. Don't forget to like and subscribe to Lumen Spiritus for more captivating content. Your support is really important to our channel. Tell us in the comments which topic you'd like us to explore next.